Welcome to section 2. Today we're going to add and subtract rational expressions. What prior knowledge you'll need. A couple of things really stick out when I looked at this lesson. You're going to have to add and subtract fractions. Alright, this isn't going to look like the typical adding and subtracting of fractions, but we're going to have to get common denominators just like the most basic fraction operation that you'll ever see. So that's something that we're going to have to keep in mind. We're also going to find the least common multiple and use that as the denominator of this fraction. So when we get there, we'll talk more about that. And then the last portion is when you do fraction addition and subtraction, you're going to have to do the operation on top, so add or subtract, and then you're going to keep the bottom, the common denominator, the same. Some strategies that we're going to use that are going to help you. If you can factor things, you always want to factor it, and that starts with pulling out the GCF. Anytime there's something that is common to everything, you want to pull that out. And again, if it can be factored, we take it that step and we factor it every time. The next one's going to be a huge one. We're going to put parentheses around each expression. We're going to do this very first step every time on these problems. It's going to help us organize it, and it's going to help us keep these factors separate. And then the last part, if you multiply the bottom of an expression, you must also do the top of the expression. So what this looks like is when you do something that says you're going to multiply it by x plus 2 on the top, we have to do it by x plus 2 on the bottom, because this is essentially multiplying by 1. Anything over itself is 1, so we're not changing the value, we're just changing the way that it is written. We're going to first work on finding the LCM, or the least common multiple of 3 terms. The easiest way to do this is to factor each term and see the maximum number of times a number or a variable is a factor, and we're going to take that. So we're just going to start by factoring it. So if you do 18 and you factor it, what you get is you get 2 times 3 squared, so 2 times 3 times 3, and I did this by making a factor tree. And then I have r squared and s to the 5th. I think the numbers are the most difficult part of this. So when I factor 24, I get 2 to the 3rd times 3. And then I keep my variables. And then when I factor 15, I have 3 times 5. And I keep my variables. So at this point, I look at each variable or each number and see the maximum number of times it occurs. So 2, it occurs once here, 3 times here, and none here. So I'm going to take the maximum times, which is 2 to the 3rd. I'm also going to look at the 3. It occurs twice here, it occurs once here, once here. So the max number of times is 2. And then r squared occurs twice here, 3 times here, none here. So I'm going to have to keep the 3. S to the 5th is the largest. And now I have to consider the t. There's t squared and the t. So I'm going to keep the t squared. And the last portion that I almost forgot was this 5. The 5 occurs one time. It doesn't occur any other times over here, so it is a 5 here. When I multiply these all together, what I get is 360 r to the 3rd, s to the 5th, t squared. And I want to say that's what the LCM is. When we get to fraction operations, this is going to be important. We are going to list this out separate because we want to know what we're trying to get to. The second example is if you have polynomials. Remember when I said earlier, if you can factor something, always start there. So what I'm going to do is I'm going to start by factoring these two. The first one, I can pull a p out. So now I have p squared plus 5p plus 6. So now if I factor this one more time, I can say it's p plus 2 and p plus 3. The outside p still stays there, and then I'm going to factor the second one, and it's going to be p plus 3 and p plus 3. Now we have the same idea when we're finding this LCM. We find the maximum number of times a certain term occurs. So here there's a p. There's not a p over here. We still have to include it. It includes it, the p to the first. one time. Now we have p plus 2. P plus 2 occurs over here. It doesn't over here. We still include it because we're looking for the maximum number of times. And then p plus 3 actually occurs twice here. So we have p plus 3 and it's squared. This is our LCM. So we factored everything. We found out the number of times, the maximum number of times each factor occurred, and that's what we write down, and they're all multiplied together. That's how we find the LCM. Let's practice this on how that applies to when we do these fraction operations. So we first want to look at the bottoms and say, how can we find the LCM of these two? Using previous methods, we can find that the LCM of these two is 90xy squared. Now the reason that this is important is when we're adding fractions, we have to have the bottoms the same. We have to have these common denominators. So this LCM is going to serve as our common denominator. So I'm just going to go ahead and write this on the bottom of both, and then we're going to see how we get there. So let's start with this first one, 18xy. What do we multiply it by to get 90xy squared? Well, 90 divided by 18 is 5. We have x's match, and now we need one more y, so it's 5y. Here we're going to multiply it by 5y over 5y, because we have to essentially multiply it by 1. So what we do here is we have to multiply y times 5y. Gives us 5y squared. Now we look at this and we say, what times 15 gives us 90? And that number was 6. Now we already have the y squareds to match here, but we do need to multiply it by an x as well. Notice I'm putting parentheses here to show what is being multiplied. A good double check on these is to actually multiply these bottoms together and make sure that you get your desired denominator for down here. Then we can physically do the operations up top and we get 42x squared. At this point, we have common denominators, so we can add these fractions. So what we do when we add fractions, we take this top, we add it to the second top, so we have 42x squared plus 5y squared. And then the bottom stays the same, and we are finished. So we used fraction operations, we used least common multiple to get to this solution. Notice each time we multiplied by 1. Again, a good double check is to multiply these bottoms and make sure that you do get to 90xy squared. All right, the next example. Something that's a good habit to get into is to just around each term or each factor, we're going to just put parentheses. This kind of keeps everything separate and says we're multiplying these things together, so they are factors. So when we find this least common multiple, we keep that in mind. If we look at the numbers, 8 is the largest number that occurs. And if we really wanted to break it down, we'd say 2 to the third, and then we'd look and see how many times 2 occurred. M squared and m, the highest one out of that is m squared. N and n squared, the highest one out of that is n squared. So our LCM, which we do want to write out here, is 8 m squared, n squared. And how we're going to use that is we're going to take that, and that's going to be our bottom, our common denominator. So we have to ask ourselves, what do we multiply this piece right here by to get down to this common denominator? So we definitely have to multiply it by an 8. We also have to take this m and get it to m squared, so we have to multiply it by an m. N squared and n squared match, so we know that when multiplying, this is what we're going to multiply by. We have to do top and bottom by it. The top becomes 16m. This one, we treat them individually. So this, what we multiply the first fraction by will be different than what we multiply the second fraction by. We have to get 8 to 8, so we don't have to worry about multiplying it by a number. It's already there. m squared to m squared. They match. N to n squared. So we have to multiply by an n. So we get one n on top. And again, if you can check that bottom, you're going to make sure that you're getting to where you get to. And you're not going to have any slip-ups on choosing the wrong thing to multiply by. At this point, we take n plus 16m. And again, if this was a minus sign, we would do minus. And then we keep that bottom the same. And we're finished. Anytime we're looking at this, especially when we have polynomials here, I recommend putting these parentheses around each thing because this shows, hey, these are factors. Now we're going to take this and we're going to factor it because anytime we can, we want to. So w minus 4, we can pull out a 2 here, and it's w minus 4, so that's going to be convenient. Now we look at our bottoms and we say, these are our new factors. So out with the old, in with the new. Our LCM here, 4 and 2. That would be a 4 because we have 2 times 2 and just 2 alone. So 2 times 2 is the largest one. And then w minus 4 is in both of them, and it's just in there one time. So 4 w minus 4 will be our common denominator. Now we have to see how we get there. So on this right side, we had on the bottom 2 and w minus 4. We want to get that 2 to become a 4, so we have to multiply it by 2. We have to get that w minus 4 to a w minus 4, so we don't have to multiply it by anything else. On the top, we're going to take it by 2. Notice the notation that I'm using. I'm keeping that 2 out front. The w plus 4 is still there, and we're still multiplying them. On the first one, we have 4w minus 4 and 4w minus 4. These two are the same, so we don't have to worry about multiplying it by anything to change it. We already have those common denominators. So what we do on the top is we say, this is w plus 12 minus 2w plus 4. And our bottom stays the same here. At this point, we do want to simplify this piece up here and then combine our like terms. So we have w plus 12 and then minus 2w minus 8. And then combining our like terms, I'm going to work to the left here just for space. I'm going to have negative w plus 4. And now comes that tricky portion where we have to factor out a negative 1 to get these two terms to match. So we have w minus 4, and this actually becomes negative 1/4 as our answer because things have canceled out. Notice at this point, we could not just cancel things out because this was an entire factor, and so is w minus 4. So we have to be aware of that every single time. 4b and 4c will be done as supplementary videos, so look for those in a different section if you need an additional example. So we're going to move to example 5, complex fractions. Complex fractions just means it's a fraction over another fraction or a fraction divided by a fraction. So what we want to do is we want to consider just the top first and then just the bottom and get these down to just a common fraction on top, so one fraction and then one fraction on the bottom. So just working with the top, our LCM of the top will be x times y. So in order to get that for this first one, we have to multiply it by y over y. We get y over xy. Here we have to multiply it by x over x. So we get minus x over xy. So for the top, we have y minus x over xy. And I'm just going to keep that as the top. Now we're going to work with the bottom. When multiplying this, or adding this rather on the bottom, our least common multiple is going to be just x. So I'm going to rewrite this first one as x over x, and it's plus 1 over x. So I have x plus 1 all over x. At this point, I rewrite it as a division, and then I'm going to flip this second portion make it multiplication, and simplify to my answer.